Hello, students, and welcome to a review for your upcoming SAT practice exam. This video is another support video for you, the student, for tackling common SAT test questions. The SAT is a exam given to high school students in preparation as a benchmark for their college goals. And here at Chang Learning, we offer a full modular course of 28 lessons to prepare on 28 topics that are commonly on the SAT. To get started with this video, think of one common mistake that you make when solving a difficult math problem. And I'll give you 30 seconds. Okay, so most students, when they raise their hand and they brainstorm about this question for a moment, then they come up with answers like, well, I'm pretty good at math, but I forget the formulas. I didn't have the formula memorized, so I didn't know what to do. Or I didn't know how to translate that word problem into an algebra equation or an algebraic expression. Another common mistake that's important to master for the SAT is, well, I was doing Pemdas and I did it in the wrong order. Or it was a system of equations and I did the wrong method. I eliminated, or I did the elimination method wrong, or I did the substitution method wrong. In geometry, again, I couldn't remember the formula. I couldn't remember the formula to use for area or volume. And also with Sohcahtoa, I couldn't remember even what that meant, but I remembered that we had a lesson called Sohcahtoa. And for those three problems, I didn't know what to do. The last thing that's a mistake when solving a difficult math problem when it comes to the that was mentioned is time management. It's like, hey, I was pretty good at math, but I keep running out of time when it comes to a problem on a test. So that's a good related response to this icebreaker. Well, for the math exam itself, the SAT math section, it's a review of your high school, middle school, and high school mathematics. The questions on the SAT will focus on algebra, geometry, the coordinate plane, charts and graphs, probability and statistics, and a few other math topics. The mathematics sections are two. The first is SAT section 3. No calculator is allowed. The entire section is 25 time minutes for 20 questions. Section 4, the math test, you are allowed to use a scientific calculator. The total time is 55 minutes, and there are 38 total questions. Here is a page from the first lesson that I wrote for Chang Learning, and it was the SAT overview, basic algebra review. Here you can see what I just stated from the previous page on section 3 and section 4. Notice that the exam is split up into a multiple choice section. Here there are 15 multiple choice, section 3, and 5 grid in. In section 4, there are 30 multiple choice and 8 grid in. The other thing to note is that the high percentages in section 3 are in the algebra section and in the algebraic expressions and quadratics. That's mostly in section 3. In section 4, about 30% algebra. It's algebra heavy, but the problem solving and word problems are in section 4, as well as charts and graphs representing quantitative data. And those are more heavy in section 4. It's about 3/4 of the exam in section 4. The other topics, geometry and of geometry, are about 15% of the questions in section 3 and 10% in section 4. So you should expect 3 to 4 questions in geometry in section 3, as well as 3 to 4 questions in geometry in section 4. Remember that this is the Scholastic Achievement Test to be a benchmark metric for your academic high school progress. It's taken by actually up to 2 million students every year. There is another exam called the ACT, which is also taken for college. Please keep in mind that the ACT has more geometry than the SAT. So if you're planning on being an engineer or an architect, or even go to medical school, often those programs will ask for not only the SAT score, but the ACT, where more geometry is tested. So to get ready for the SAT, it's good to enroll in an SAT preparation course because it helps you get organized with the topics that are year after year, semester after semester on the SAT. So the course that I sequence for Chang Learning here begins with algebra and algebraic expressions, linear equations and inequalities, quadratics, other types of functions, as well as circles. Then transformations on the plane and logarithms and natural logs from Algebra 2. Then going to geometry, we begin with angle relationships, the Pythagorean Theorem for right triangles, areas of composite shapes. Those are triangles, squares, rectangles, trapezoids, circles composed together, volume, Sohcahtoa, and unit circle trigonometry, and ending the geometry and trigonometry with law of sines and complex numbers. Mostly in section 4, you have bar charts and histograms, pie charts, two-way tables, double-line tables, and then just a few probability questions. Again, less than 10% of the exam on mean, median, and mode, and the statistics of the normal curve. Another good beginner strategy is to note that on the SAT, it's like a college math course, or a high school math course for that matter, where the course begins easy and gets more difficult as you move along with the material. So you'll notice here, I put these green blocks on the screen in section 3 for questions 1 to 5. And you can see here with this arrow that all the questions numbered 1 to 5, that's 01, 02 up to 05, are level 1 or level 2 in difficulty on a scale of 1 being easy level and 5 the most difficult. Similarly, in section 4, the first 10 questions are a combination of levels 1 and 2 type questions. There's one level 3 question in this designed SAT. Then proceed with caution as the questions get more difficult. Focus on your math. The steps have the questions have a few more steps in these mid-level problems. And you can see that there are also some level 3 and 4 questions in the mix for questions for the next third of questions. That's questions 6 to 10 in section 3 and 11 to 20 in section 4. And finally, then the multiple choice ends with the 5 most difficult questions. So I'll put a red flag on those. So you can see that those questions are level 3, 4, and 5 mostly. And also in section 4, the last 10 questions are the most difficult. Then when you enter the grid-ins, when you go to the grid-ins which are not multiple choice, you have to write out your student response in the bubbles. So you'll see that the first half are usually levels 1 to 3, and the second half of the set are the harder problems. So again, it returns to the first half being levels 1 to 3, and the more difficult problems usually at the end. Although the writers of the SAT have some crossover, this is the basic floor plan, the basic map of the difficulty of questions. So that means that for most students who have problems with time management, who run out of time on the test, it's a good idea to do these questions. Questions 1 to 10 and 11 and 1 to 20 in section 4. Those 30 multiple choice questions. And then, if you have enough time, do the first half of the first 3 gridding questions and the first 4 in section 4. So then you've answered 37 of the 58 questions. However, notice these questions, these 37 questions, are usually much easier level than these red block questions that often take the average student 3 to 5 minutes per question. But if you can get all 37 of those questions, you already have an SAT score above 500. Up to 600, if you get most of those 37 questions, you have a 600 math score out of the top score of 800. So a good practical beginner strategy is to do the 13 questions in the green boxes, questions 1 to 10, 16 to 18, then go back if you have enough time and do those other 7 questions. For section 4, do the first 20, then go right to the grid-ins and do those 4, that's 24 questions. And then if you have the extra time, so remember there's only 55 minutes total, then go back and complete the other questions in section 4, the other 14 questions. All right, this is a very practical and useful strategy for getting a higher score on your SAT. Now let's focus on the topics one at a time. And just in this video, we'll do a few sample problems from each type of question. The algebraic problems on the SAT require knowledge of Pemdas, parentheses, exponents, multiply and divide, add and subtract, which are the order of operations for use in algebra. Next, linear and quadratic word problems are a great portion, over a third of the exam, up to half of the exam. Linear equations are of the form y equals mx plus b, usually. But there is also standard form and point slope form. Adding or subtracting 2 linear equations. And there's also a system of shortcuts that are designed in the problems on the SAT. So reviewing PEMDAS, here are a couple of examples on the right side where you can see parentheses, exponents, multiply, divide, add, and subtract are used in procedure with a algebraic expression. The expression is done by doing the parentheses first and simplifying those. Here, 15 minus 2 is 13, and 4 divided by 12 is a third. Then, after rewriting the line simplified, start again at the beginning, read through it once again, do the multiplication steps and division steps, and it simplifies to 26 divided by 4 plus 3 minus 1.5. Again, doing the division step, 26 divided by 4 is 6.5, plus 3 minus 1.5. And then we get 9.5 minus 1.5, and the correct answer is 8. For the second problem, it's double parentheses, but you follow the same steps, doing the inner parentheses first. If you follow the procedure of PEMDAS, the final simplified result is 14 for this expression. In example 2, proportions and cross multiplication, this is another basic algebra skill that's very useful for the SAT. When expressions are set equal to each other, but they're both fractions, you can do the cross product and multiply across the diagonals. So I'll highlight this with a double arrow. So we multiply across, and we get x, and then multiplying the other diagonal, 2 times 3x minus 1. Distribute the 2, and down below you see here when we cross multiply that 1x equals the other diagonal multiplied, 2 times 3x minus 1. 1x is 6x minus 2. Subtract 6x, and then divide both sides by -5. And the correct answer is 2/5, or 0.4, which is A in this multiple choice. Here's an example that's commonly done on the SAT. Question 11 here is shared. If 5x plus 6 equals 10, what's the value of 10x plus 3? See if you can find a shortcut to find the value of that expression based on the equation that's given. Can you think of a shortcut that relates the 5x plus 6 and the 10x plus 3? Well, some students say, well, it's easier for me first to subtract 6 from both sides. Then 5x equals 10. And then double both sides. So 10x equals 8. And then, since we know 10x is 8, just add 3 to that. And we get 10x plus 3 is 11. Another student responded, well, why don't we just double the entire equation first? So instead of 5x plus 6 on the left, we have 10x plus 12. And doubling the right side, we get 20. But we didn't want 10x plus 12. We just want 10x plus 3. So subtract a 9 from the left and the right side. And then we do minus 9 on the left and minus 9 on the right. You see that we have the equivalent answer, 10x plus 3 equals 11, because 20 minus 9 is 11. In the next example, if k is greater than 0 and x equals 7 in the equation below, what is the value of k? Well, here you want to isolate the radical and then square both sides. So knowing this is very important, your basic algebra skills from 9th grade algebra. So first we add x to both sides, and it's the square root, I just wrote RT, of the expression inside. 2x squared plus 17 equals x. I know that if I have x equals 7 is given, I can now place that on the right side. So the square root of 2k squared plus 17 equals 7 as given. Square both sides, and the square root symbol is eliminated on the left, and we have 2k squared plus 17 equals 7 squared, which is 49. Subtract 17 from both sides, so 2k squared is 32. Divide both sides by 2. That means k squared is 16, and then take the square root, and k is 4. The correct answer was C, 4. For the next problem, the Borealis Lighting Company sells special bulbs that last for many years. However, each bulb costs $99 plus $8.25% tax. What is the total cost of 6 of these items? Round it to the nearest dime. Well, there certainly is a shortcut here. It's very difficult to spend your time when you don't have a calculator doing 99 times 0.0825 and finding the exact tax. But if you round the price of the light bulb to $100, just round up, then it's easier to do the tax, because $100 times 0.825% is $8.25 of tax on each light bulb. So that means that each light bulb plus tax, if it was $100, would cost $108.25. Since you're buying a set of 6 of these super light bulbs, that's 6 times 108 and a quarter. Well, 6 times 108 is 648, plus 6 quarters is $1.50. So it's a grand total of $649.50. So you're looking for an answer choice that's less than $649.50, which was choice B. So the only answer that it could be is choice A, $643 rounded to the nearest dime. The reason being is that the actual cost was $1 less per bulb. So you should look for an answer that's about $6 less than $649.50. And in fact, you save $650. Correct answer is A. Okay, because the light bulbs aren't $100, they're $99, but we rounded up to do easier math. So this is a real time saver. So you get the same correct answer in just 2 minutes, or even 1 minute on the SAT, when it took another student 5 minutes to do all the math for question 3. Okay, so remember to do rounding and estimating when possible on an SAT question. For the next problem, you have to be a fluent reader and know your conversion units. So if H hours and 30 minutes is 450 minutes, what's the value of H? Well, use a quick table here because you know that 60 minutes is 1 hour. So then I just write it out fast, right? Sometimes you don't even have to do the math. You just have to write a list until you get beyond 450 minutes. So I know that 420 minutes is 7 hours if I make this quick table. That takes me like 10 seconds. Then I know that, oh, that's 420. There's an extra 30 minutes. Aha, H is 7. It's 7 hours and 30 minutes. The correct answer is 7. Other student says, yes, it's just as easy to set up the linear equation because I'm good at algebra. 60 times the number of hours plus 30 minutes is 450 minutes total because there are 60 minutes in an hour. Subtract 30 from both sides and you get 60H is 420. Divide by 10. It's easier. It's 6H equals 42. Aha, divide by 6 and H is 7. Same correct answer, 7. So whether you make a quick mini table, if it's right, if the number of hours is like between 1 and 10, you can make that list pretty fast. If you know the conversion rate, you can make a list of like the first 10 multiples of the unit rate. Otherwise, use the system of algebra as you learned it. Some students say, yes, I can do algebra, but this is faster for me. It's like a puzzle, and I just do it faster. Okay, so use the skills that save you time for the more difficult questions on the exam. Here are some examples of linear equations of the form y equals mx plus b. A restaurant delivery worker earns $10 per hour plus $8 for every food delivery completed. If the employee works part-time for a week for 18 hours and makes a total of 16 deliveries, how much will this person earn in total? Well, here we set up an equation for the two ways that the worker earns money. It's $10 per hour, or 10H, plus $8 for each delivery on the job, 8D. Since this person worked 18 hours total and made a total of 16 deliveries, we have H equals 18 and D equals 16 for a total of $118 for the hours at the restaurant and $128 for the deliveries that were done for the same restaurant, for a grand total of $308 earned by that person as the delivery worker. For a system of two linear equations on the SAT, it's important to know that there is always a shortcut, whether it's substitution or elimination, or add and subtract them together. Here's an example of an SAT word problem of two equations that has a very fast shortcut. Question 7. McCoy Max Speed Incorporated makes custom skateboards for its customers. 2 wooden skateboards and 5 composite skateboards cost $900. So here I've taken that sentence and I've written the first equation here. 2 wooden skateboards is 2W, and 5 composite skateboards is 5C, and the total for that cart of items is $900. Second person comes in and says, well, I want 3 wooden skateboards and 2 composite skateboards. And the shop says, well, that would be a total of $750. The question is, how much would McCoy Max Speed charge a customer who purchases 5 wooden skateboards and 7 composite skateboards? Well, you can solve by elimination, making the coefficients the same, like multiplying the first equation by 3 and the second equation by 2. And then you can eliminate variable W and find the cost for one composite. But the shortcut here is to put the orders together. And this saves, again, about 5 minutes on the exam. Look for these shortcuts where you can either add the equations together or subtract one from the other. Here, if we put both orders into one giant cart, we'd put in the 2 wooden, 5 composite, 3 wooden, and 2 composite, and just add column-wise. Okay, so you can see here that if we change the order to one giant order, they pull them together, 2 plus 3 is 5 woodens, and 5 plus 2 are 7 composite skateboards. Well, you just have to add the cost for each separate order as a combined order. 900 plus 750 is 1650, and that was the SAT shortcut. I guarantee you that at least one or two of the problems on the SAT with systems of equations will have this kind of shortcut, where you either add the two equations together or subtract one from the other. In the next problem, which of the following ordered pairs satisfy the system of equations below? We have x plus y equals 0 and 3x minus 2y equals 10. Well, one type of shortcut is to take the ordered pair and plug them in, and they have to work for both equations, right? So if it's the intersection, the x and y values work for equation 1 and equation 2. Well, that will eliminate choice A, because x plus y must be 0. They must be the same value but opposite signs. So for example, 3 plus minus 2 is not going to be 0, but a pair like 2 and negative 2 is possible, or negative 2 plus 2, that equals 0. So that's possible. And D also doesn't work because negative 2 plus negative 2 is negative 4. That's not 0. A fast way to do this, to find the system of equations, is to double the first equation first. Okay, remember, we're only considering choices B or C. But if you double the first equation, then you can see that you have 2x plus 2y now equals 0. Wait a minute, it went back. Ugh, how do I go backwards on the slide? It's only going forward. Ugh, sorry, hold on just a moment. So then we have 2x plus 2y equals 0. And then you can add column-wise. 2 plus 3 is 5x. 2y plus minus 2y, the y's cancel. And 0 plus 10 is 10. Now we add the equations together, and we've eliminated variable y. Divide both sides by 5, and x is 2. Well, the correct answer is choice B. That's the only choice where x is 2. And it will work for both equations if you plug in that value for y. So since there are only 4 choices, you can plug in the numbers to solve it. That might be fast. Or you can use this shortcut pattern. Double the first equation and then add them together. For the next one, we have another system of linear equations where k is a constant and x and y are variables. For what value of k will the system of equations have no solution? Well, kx minus 3y equals 4, and 4x minus 5y equals 7. So what we can do here is we can multiply the first equation by 5 and the second equation by 3 so that we get the same value in the y column. So I'll highlight that here. We're making this column the same. The 3 and the 5, we're making them both 15y. Then we see that 5k minus 15y is 20, and 12x minus 15, it's 5kx minus 15y equals 20, and 12x minus 15y equals 21. So that means that since the lines are parallel and they have no solution, that means that 5k equals 12, because the ratio or the slopes have to be the same if lines are parallel. So when lines are parallel in standard form, the coefficient in front of y is the same, and the coefficient of the x is the same, so that the slope ratio, the change in x and the change in y, are equal. Then we have 5k equals 12, because this number must equal the coefficient 12. Divide both sides by 5, and k is 12/5. The correct answer is A. So if k is 12/5, the lines will be parallel, meaning they won't intersect and they will have no solution. The next topic that is in mass on the SAT, meaning there are at least 10 questions related to these topics are quadratic equations. Here I presented from the core lesson, the modular lesson, some useful formulas that are not on the formula sheet. And I remember when I took the SAT that I scrambled to write down the quadratic formula right when I sat down with the packet when they said I could write. And I wrote down axis of symmetry, and I wrote down Sohcahtoa, because you need to add that to the SAT formula sheet. Here for quadratic equations, you see an example where it has 2 roots. Here's an example where it has 1 solution with the x-axis. And here's an example where the parabola is hanging above. So it swoops down, but it doesn't touch the x-axis, and then it swoops back up. So those are 3 of the common types of equations that you'll see on the SAT. 2 roots, 1 root, or no roots. So 2 zeros, 1 zero, or no zeros. As an example, in this parabola PQRS, PQRS is a square, and point Q, R, and O lie on the graph of y equals ax squared, where a is a constant. If the area of the square is 64, what is the value of a? Well, as we can see here, this is a square. Here, let's see, so that's 8 by 8, because the area is 64. So that means that since it's split in half at 0, and the side from P to S is 8, that means that it's going to be between -4 and 4, since the axis of symmetry is the y-axis. So mapping the corner points, since this is 4, 0, it's 8 units higher, the entire side length, so 4, 8 is 1 point at point R on the parabola. So since we know when x is 4 and y is 8, that is on the parabola, plug that into the parabola equation, y equals ax squared. And we get 8 equals a times 4 squared. Square the 4, and we get 8 equals 16a. Divide both sides by 16, and a is a half. Correct answer is, for this shaped parabola, that a has to be a half. For the next question, which of the following is equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A can be identified as constants in the equation? Well, here, write down the equation above, and we're going to complete the square and put it into vertex form. So the way you do that is you set the terms to the left, you move the constant away to the right, and then to find the value that goes on the blank line, you take half of the middle term and then square it. So half of -2 is -1. -1 squared is 1. So you have to add 1 to complete the square. So the square is now completed when we add 1. Well, you can't just add 1 to the right side of the equation. So it's tradition to, outside that trinomial, subtract the same amount. So we're adding 1 and subtracting 1 at the same time on the right to keep balance. Then we have x squared minus 2x plus 1, which is the perfect square, x minus 1 squared. Since we have to subtract 1 to keep balance, we have -15 minus 1 is -16 as the k value. So the correct answer is choice D. Y equals x minus 1 squared minus 16, showing us that vertex at the point 1, -16. For the next equation, the equation above expresses the approximate height h in meters of a ball t seconds after it is launched vertically upward from the ground at initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? Well, notice that it's a parabola, so we know that at time 0, when the ball is launched, if we plug in 0, the height is 0. So that's the starting point. The axis will be the half-time point, and then it'll be back at 0 one more time as the ball falls back to the earth. So use the a, b, and c values with the axis of symmetry formula. Negative b over 2a will be negative 25 divided by (9.8). That shouldn't say 4.9, that should say 9.8, which gives us 2.55 seconds. Fix that for you here, because it's negative b over 2a. So this should say negative 9.8. Pardon me as I fix this for you guys. And that is the half-time point of the flight of the ball. It's going up, 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 and it's at the axis of symmetry, the halfway point, and then it'll fall down for another 2.5 seconds. So the ball should land at about 5.1 seconds. And the closest answer is choice D, because it's an approximate answer. It should be at about 5 seconds when the ball lands back on Earth. This question I wrote for the Chang Learning course, and the idea was a drone hovering above like the stage at a school performance or hanging above the auditorium. And the drone hovers in space at location 1531.25. Outside of the frame of the camera is along the arc of the formula P of x equals 0.05 negative x plus 40 times x plus 10. If a person walks through the field of vision of the camera at 1.25 meters per second, for how many seconds will the person be in view? Well, this is a quadratic in factored form. So we use the fact that the factors are present, that if we plug in negative 10, which is this star point here, then we'll get 0.05 times some number times 0. So that will be one of the 0 values. Also, if we plug in 40, we'll have 0.05, which is this first factor here, times, well, this will be 0 because that'll be negative 40 plus 40, that's 0. So a number times 0 is 0, times whatever, times 50 is 0. So we get another 0 on the map if we plug in the number 40. Those are the only two numbers which we can see by the factored form. There's a special value here, 40. If we plug it in, the product will be 0. And there's a special value, negative 10. If we plug that in here, same thing on the picture, we'll see root because it's 0.05 times a number times 0. And anything times 0 is 0. So that's how you use factored form. Use the additive inverse to find the locations of the roots. So the person's walking across the stage. If you just follow this black arrow, the drone will see them in view here when it enters its cone of vision. And then, like the person walking across the stage picking up their diploma. And then all the cameras are taking photos, and then they're out of the picture view as they walk off and walk back to their seat, right? So that kind of situation. So the person walks a total distance between negative 10 and 40 or 50 meters. And since they walk at a pace of 1.25 meters per second, take 50 divided by 1.25, and you get the correct answer of 40 seconds in the field of vision of the drone camera. So the drone will see this person walking by in its view for 40 seconds. One last note on the SAT is occasionally, as a challenge problem, they'll have a parabola that's sideways. right? So most SAT questions are with functions of probability either up or down. But if you switch the x and y variables, which I have in this formula here on the right side, then you get these two parabolas, right? If a is positive, it opens up. If a is negative, it opens down like this. Here's two examples. However, if x and y are switched, you can have a parabola that shines open to the right or that opens up to the left from its vertex. The next topic that is always on the SAT is the topic of factoring patterns. Here are 3 factoring patterns you should memorize for your preparation for the SAT. X plus y times x plus y equals x squared plus 2xy plus y squared. X minus y times x minus y is x squared minus 2xy plus y squared. X plus y times x minus y is x squared minus y squared. In this sample problem number 5 from the SAT, when 3x plus 5 times 3x minus 5 equals 11, what's the value of 5x squared? Well, here you just have to know the FOIL pattern. Multiply this pattern out, and you see that it's 9x squared minus 15x plus 15x minus 25. And just like equation 3 on the last page, you now have the middle terms cancel. So negative 15 and positive 15 cancel, and you just get 9x squared minus 25 is 11. Add 25 to both sides, and 9x squared equals 36. Divide both sides by 9, and x squared is 4. But we wanted 5 of those squares. So multiply both sides by 5, and you get the correct answer, C, 20. For the next problem, we have 6x plus y squared equals 121, and x minus y squared equals 41. What is the value of xy? The shortcut here is to multiply both of them out using FOIL. Then you get x squared plus 2xy plus y squared equals 121 for the first equation. And for the second equation, which I'll highlight in blue, you get x minus y, x squared minus 2xy plus y squared equals 41. Then the shortcut is to subtract the second equation from the first. X squared minus x squared is 0. 2xy minus 2xy is 4xy because of the double negative. Y squared minus y squared is 0. And on the right side, 121 minus 41 is 80. Excuse me. The squares get eliminated by subtraction. So then we have 4xy equals 80. Divide both sides by 4, and x times y equals 20. The correct answer is A. In the next equation, which of the following is equivalent to the expression below? X squared plus 6x plus 4 Again, this is a problem in completing the square and writing the equivalent expression. Move the constant to the right. To complete the square, take the middle term, divide it by 2, and square it. 6 divided by 2 is 3. 3 squared is 9. So we have to add 9 units to complete the square. Since we're adding 9 units to the expression, we have to subtract 9 at the end to keep balance. Now the trinomial is ready to be packed up as a completed square. We have x squared plus 6x plus 9, the trinomial, which is x plus 3 squared. 4 minus 9 is negative 5, and we get the completed square is x plus 3 squared minus 5. The correct answer was B. The The last type of factoring that needs to be covered for an SAT are the four-term factoring patterns. Here, focus on the front two pairs and the front pair and the back pair of these four terms. So here, I'm just focusing my attention on these two terms and how to factor them, and the back two terms and how to factor them. So the greatest common factor for the first two terms is x squared. If I move that out to the left from each of these two terms, I get x squared times 2x plus 3. For the back pair, the greatest common factor is -9. But lo and behold, I have the same binomial 2x plus 3 once I factor out that -9. Now we can make the new binomial, x squared minus 9 times 2x plus 3. And that is the binomial pair for these four terms. Since this is a conjugate pattern, x squared minus 9, we can rewrite that as x plus 3 times x minus 3. So the completely factored form is x plus 3, x minus 3, and 2x plus 3. This gives us the solutions when it's equal to 0 of -3 and 3 and -1.5. So the correct answer was B. Although algebra is over a third of the SAT problems, there's also almost a third of the problems in geometry. And it's very important in geometry to use the provided SAT formula sheet, which is the first page of the booklet of each section of the SAT. Some of the problems will have two-dimensional area compositions. Some will be in 3 dimensions with volume or surface area. Problems will also include the Pythagorean Theorem and Sohcahtoa. This is the formula sheet that's given to you on your SAT booklet. And you can see that most of the important mathematics formulas are included on the first page of each section of the SAT formula sheet. Note that not all the formulas are on the test are provided there. Below the page are more common formulas and mathematics facts that should be known to prepare you for the SAT. We can see here the geometry problems include knowledge of circles, rectangles, triangles, rectangle prisms, and cylinders, most commonly, as well as right triangles, and there's the Pythagorean theorem below, and these two special reference triangles, or workman's triangles. You'll find in any worker's toolbox a 30, 60, 90 right triangle and a 45, 45, 90 right triangle, because those shapes give the ratio of sides that are useful in building things and the angles that are needed in construction. So here the short side is x, the long side is x root 3, and the hypotenuse is double. The way to memorize this is that the short side is x and the hypotenuse is double, is 2x. Here, these two sides are the same because it's an isosceles right triangle, and the hypotenuse is x root 2, the side root 2. The other two facts that are provided for you as reference is the conversion that a circle is 360 degrees total, and that the measures of degrees in a triangle are 180. Here is a problem in geometry which tests your knowledge of the formulas on the previous page. Question 17. If a 10 meter by 10 meter rectangle garden has a 1 meter gate at the top left and a lower right along the diagonal path across the area made of gravel, what is the area of the shaded gravel path? Well, what I'll do is I'll try and highlight for you this garden path. So you can see here, the gate is just 1 meter, but the garden is 10 by 10. So this side of the triangle below it is 9. The exit gate of the garden is here. It's on the bottom side. So you can enter on the left and exit down here as you walk along the black graveled path. But the entire length of the square is 10, so 9 plus 1 is 10. This side of fencing from this corner to this corner is 10, and this side is 10. So we get a small triangle down below, and we get a large triangle above. Okay, so finding the areas of the square itself, which is 10 by 10, and then subtracting both triangles will give us the amount of area of that trapezoid-shaped path, this path that's going along with a smaller flower bed below and a larger flower bed above. So the area of the large triangle is half the base times the height. So it's half of 10 times 10. The area of the smaller triangle is a half of the base times the height. Well, the base is 9 and the height is 9. So the area, recapping, the area of the small triangle is 40.5. And the area of the larger triangle is a half of 10 times 10, a half of 100, which is 50. Adding both those areas together, you get 90.5. Then do 100, the entire square, minus 90.5, and you get that the amount of gravel needed for the garden path is 9.5 square meters. Question 19. A cylinder bucket has a radius of 6 inches and a height of 12 inches. A child has a plastic cone that scoops up the beach sand that has a radius of 3 inches and a height of 6 inches. How many scoops of sand are needed to fill the cylinder 2/3 to the top? Well, for this question, find the volume of the bucket. The bucket is the base shaped, which is a circle, pi r squared, times its height. So that'll be pi times 6 squared, 36 pi, times a height of 12. We get 432 pi. The cone that the child scoops with is a third pi r squared times the height. And it has a radius of 3 and a height of 6. So we have a third times pi times 3 squared times 6, which is a third of 54 or 18 pi. So the number of scoots needed will be 432 pi divided by 18 pi. The pi's cancel. So we have 432 divided by 18. Can divide top and bottom by 2. That would be 216 divided by 9. Divide top and bottom by 3. You get 72 divided by 3. Divide by 3 again, and that would take 24 scoops of sand for the child to fill the bucket. 2/3 to the top. Wait a minute. Did I just figure out how much it would be to fill it all the way to the top? I think I did. So I think that's the wrong answer. So to fill it 2/3 to the top, that would be 2/3 of 24, which is 16. The correct answer is A. C is the trick answer. So be careful. We only have to fill it up 8 inches. We don't have to fill it up all the way to the top. Okay, so that's a typical trap answer. C is not the correct answer. The correct answer is A, 16. So we only have to fill up the bucket 2/3 of the way, okay? So the correct answer is choice A. So watch out for those extra steps that are in the problems as presented. The next topic in geometry that's always on the SAT is the Pythagorean Theorem. Now everyone should have memorized c squared equals a squared plus b squared. Here's a list of a clay worker's tablet from the Babylonian Empire. It's not understood if this was an architect foreman, someone in charge of a site, but they had inscribed these 13 triangles, right triangles, and included on the list, translated from ancient cuneiform, which is the system of wedge cuts here. One of the 13 triangles, for example, is the 3, 4, 5 right triangle. Another one is that same one scaled up by 15. There's also more unusual ones such as 16, 72, 97 is a Pythagorean right triangle. So they seem to have different ratios, like this set of triangles here that I made a picture of for construction purposes. So depending on like the slope step or the ramp of a ramp that you're building, or a design, I don't know, of stairs or temple columns, the steepness is determined by these slope ratios. So it's unknown if this was a list of all of the different shaped triangles that are needed to construct this temple or this building, for example. But that's the intuitive answer, that this was like an architect's short list of the shapes of triangles that were needed to build the entire structure that they were in charge of constructing. They need the triangles as long as the sides are in that ratio. Here's an example of a different type of real world problem, flying a kite, and the right triangle that's formed by the kite flying overhead in the breeze. Question 16. Mary and Betty Ann decide to fly a kite together. So Mary ties a kite to a stake. They plant it in a field, and her friend Betty Ann walks 40 feet away from the stake and releases the kite up into the air. The kite rises over her head. It's very windy, and the 50-foot string is under tension and straight as a bowstring. How high is the kite above Betty Ann? Well, set it up and actually draw it for yourself if it's not drawn for you on the test. It's a very important skill to have, just doodling the problems when they're geometry. Then you'll see that, okay, there's the stake or like a giant nail that's placed into the ground, a spike that's there. Tie the kite to that, and then going up on the hypotenuse, 50 feet. Since it's directly above Betty Ann, it forms a right angle because it's straight up to the heavens and down above her friend. Her friend's here, Mary is here, Betty Ann is here. The distance apart, she measured off 50 steps because she's standing right there. Then use the Pythagorean theorem. 40 squared plus the height squared is 50 squared. And you get that 1600 equals plus h squared is 2500. Subtract 1600, h squared is 900. Take the square root, and h is 30. If you have already memorized your right triangles, you already know the 3, 4, 5 right triangle, then this side must be 30 because it's just 10 times larger. It's the exact same similar triangle, just 10 scaled or tenfold. So instead of 3, 4, and 5 for the sides, it's 30, 40, 50. So you too can save a minute if you already have memorized that there's a right triangle, the 3, 4, 5 right triangle. This next question from the Cheng Learning Lesson is taken from a famous, one of the, possibly the earliest textbook on mathematics from China of 250 BC. And it was from the Encyclopedia of Math called 9 Chapters on the Mathematical Art from China. And here the problem is a 10-foot long stem of bamboo is broken in such a way that the tip touches the ground 3 feet from the base of the stem as shown in the figure. What is the height of the break? Well, as you can see here, the Chinese had knowledge of the Pythagorean theorem of the sum of the squares of the legs equals the square of the hypotenuse. So although they did not call it after Pythagoras of Samos, a famous mathematician of his day, who also wrote and compiled mathematics, it was certainly known to Chinese civilization over 2,250 years ago. So here we set up a squared plus b squared equals c squared, and we have 3 squared plus x squared equals 10 minus x squared. Make sure that you FOIL the right side properly. You get 100 minus 10x plus x squared. Subtract x squared from both sides, and we get 9 equals 100 minus 20x. Subtract 100 from both sides, and we get negative 91 is negative 20x. Divide by negative 20 on both the left side and placed on the right side. We get 91 over 20 equals x. And that works out to be 4.55. So this is a very elegantly written problem on a broken bamboo stem somewhere in the lands of China resting as such, forming a right triangle. All right, really beautiful student problem there. All right, question number 20. Really elegantly written. Here's a box, a cube, that has side length 5, right? What is the distance between the center of the base of the cube and the midpoint of the vertical edge as shown? Right, so for a problem like this, what we certainly need to do is we need to find the distance along hypotenuse, but the triangle is sitting like a sailboat sail. It's upright, like if you've ever been on a sailboat on the water, that would be like the sail of the boat. So we need to know this base distance first. So first we have to find this hypotenuse on the floor, and then do the Pythagorean theorem again for the upright sailboat sail. So these problems are known as three-dimensional or double Pythagoras problems. So, excuse me, in order to do this one, we have, I guess the annotation wasn't written, so I'll write it out by hand. We have looking down on the box from above. Try and draw a nice square here for you guys. Here's the square box, the bottom of it. And since we want to know the distance from the center of the box to the corner, we know that there's this distance, and then we want the hypotenuse there. That's this black line in the drawing. We want that line first. We want this line here. So the cube is length 5. So the length of this leg is going to be half that, 2.5. And this side is 2.5. So we want to know this distance d that's along the floor of the box. This is the bottom of the box viewed from below. So using the Pythagorean theorem, we have 2.5 squared plus 2.5 squared equals d squared. But I'm going to leave it as a fraction just so you can see that sometimes it is easier to work with the fractions. So we have 25 fourths plus another 25 fourths equals d squared. Okay. So then that's 50 fourths equals d squared. So that means that d equals the square root of 50 over 2. Now, since that's this bottom side of the triangle, we know that this height here is also 5 halves because we're going upwards. And now we'll find the distance of this, like I said, sailboat sail. That's this distance. That's the distance we wanted from the center of the bottom to the midpoint of the rising side. So now we have to find that distance. So can I call this capital D? So now we have a second Pythagorean problem, which is 5 halves squared plus root 50 over 2 squared equals capital D squared. So that's 25 over 4 plus 50 over 4. The square root of 50 squared is just 50 equals d squared. So it's 75 over 4 equals d squared. But when we square root both sides, we get square root 3, square root 25, I'm rewriting 75 in a clever way, over 2. And we know that the square root of 25 is 5. So we have 5 times the square root of 3 over 2, and the correct answer is B. So you can find the distances in 3 dimensions. You can find the distance between any point in 3 dimensions. You have to just do the Pythagorean theorem on the horizontal plane, and then one more on the vertical plane, like a sailboat sail. And you too can find the distance in 3 space now. You just have to do the Pythagorean theorem twice. First with the ground triangle, which is down here in blue, this blue triangle down here. So I'll try and draw that in the picture. That's this triangle down here, these black lines. So first we do this base triangle, then we do the upright triangle, which is the second Pythagorean theorem. The next topic that is commonly on the SAT is Sohcahtoa. And here, you know that it's a mnemonic device, a memory device for memorizing these common three trig ratios. So we have so is sine equals opposite over hypotenuse. S for sine, O for opposite, and so. Cosine is adjacent over hypotenuse, ka. And the tangent function is the opposite over adjacent, toa. So although it sounds like a strange mantra of some primitive tribe, because it's with the right triangle, no, it's just a way of remembering the trigonometric ratios. Sohcahtoa, just those three syllables. Sohcahtoa. So here's an example, again, with two friends. Here's Anne and Betty, and their friends flying a kite together. Betty stands in a field with the kite spool, and Anne runs along a straight path with the kite. This time she runs out 100 feet, and the kite flows directly overhead, and the string is taut, like a bowstring again. Betty ties the string to a stake and says that she's got a protractor and that the wind is blowing the kite so that it's at 40 degrees to the ground. So the picture is drawn for you on the right. If the picture is not drawn for you on the test, you got to draw it yourself. But that's an approximate 40-degree angle. I know because if the sides are this, like a 90-degree angle straight up, and a bisected angle 45 would look like the diagonal of a square. So that's pretty good. It should be a little lower than the diagonal of a square. Two questions. How much string has been unwound from the spool? That would be this distance, the hypotenuse. And how far over where Anne is standing is the flying kite? That's h up here. Well, the reason we know Sohcahtoa in trigonometry is that if you can space out the problem as a right triangle, all you need is one side and one angle, because it's a right angle here. You either need the 40 or the 50, but that's sufficient information giving you the angles of the triangle on one side to find the other sides using Sohcahtoa. So here we go. So the string is the hypotenuse and the ground is the adjacent, and the height of Anne is the opposite side, because we're at corner B for Betty. Okay, so we're at this corner here. So the opposite side, I'll draw it in blue, Betty. That is the opposite side. The hypotenuse is always the ramp side, the tension side, the diagonal. And the side that's next to Betty, which is along the ground, viewing along the ground to her, right towards her friend Anne, is the adjacent side. So here we would use the cosine function because we're given the adjacent. We're given the 100. So this is side x. We want to know the length of the string. So we have the cosine of 40 is set up as 100 over x. So let me highlight that here. The 100 is this distance. That's the adjacent distance. And x is the hypotenuse. That is the cosine function. Adjacent, CAH. Cosine of 40 is 100 over x. Multiply both sides by x. So we have x cosine 40 is 100. Divide both sides by cosine 40. You use your calculator, and you'll get a value that's less than 1. 100 divided by the cosine of 40 is 130.5 feet. So the distance of string, which is longer, it's the long side, remember, so it needs to be over 100 feet, is truly 130.54 feet. To find the distance for the height above her friend that the kite is flying, remember this is 130.5 feet. now we want this height h. So we have to use the opposite over the hypotenuse, or we could use the opposite over the adjacent. Here the tangent is used. So again, it's from our friend Betty's perspective. So Betty is here. Now we want the opposite over the known adjacent. So set up tan 40 equals h over 100. Multiples both sides by 100, and we get 100 tan 40 equals h. Use your calculator to calculate tan 40, which is 0.839. Multiply that by 100, and you get the height above her friend is 84 feet rounded, or 83.9 feet. So the other measures of the triangle can be found out just by having one side and one angle. And that's the use of Sohcahtoa. In this next problem, a lake has two ports that are on opposite shores. A person walks at a right angle away from the dock for 50 yards. So they march like a soldier, like about face or left face, and they turn away from they're facing directly at the opposite shore where they want to travel to. So they face left and march off 50 feet and stop. They then view at the same site where they would like to travel to and see that the protractor is 65 degrees. Well, this is knowledge of right triangles in a giant scale. Since we can't walk on water, since we're not rich and don't own a boat that we can travel across, we can still do this invisible line, this measurement, because of our knowledge, our geometric knowledge of right triangles. So here, use the tangent again. The distance across the lake is the opposite side of the angle that we're given, right? So this distance, d or x, is here. That's the distance from A to B. Like if we had a boat that we could ride together, or a ferry, or had to, heaven forbid, swim across the lake. We want to know what that distance is. So march on land 50 feet on dry land, and then the tangent of 65 is x over 50. Multiply both sides by 50. And we get tan 65, which is 2.144. And the distance x across the lake is a little more than double, 107.23 feet. And the correct answer is A. For this next problem, you have to use the Sohcahtoa functions twice. First with the lighthouse and the Coast Guard ship, the right triangle that's formed, and also with the Coast Guard and the lighthouse and the sailboat. So what I'll do is I'll draw those two triangles separately. The problem reads, an 85-foot lighthouse sees a ship at a 10-degree rising angle. So that's the first sentence here. This angle here inside is 10 degrees, which means that the lighthouse light is bending down 10 degrees. Okay, so if we had a level just like the sea, a parallel line by alternate interior, that's the angle of depression. Meaning that if it was looking straight ahead, the light was shining straight ahead, that's 0 degrees, but it's tilted down 10 degrees, a depressed 10 degrees. So the right triangle that's formed by alternate interior, there's 10 degrees in the triangle there. This is the standing tower. So this is 90 degrees to the ocean, to the shore. And we know that this side is 85 feet. So there's my drawing of the relationship between the lighthouse and the sailboat out here. The second sentence says the Coast Guard ship is seen with an angle of depression of 70 degrees. So again, I'm drawing the lighthouse, which is 85 feet, but it's tilted down at a very steep angle. So that means the Coast Guard is close to the shore. It's anchored very close to the shore. So it's at the ready and ready to turn on its motor and go and help a ship that's in need. So the height on this side of the triangle is still 85 feet. But this is the Coast Guard. and the angle inside the triangle is 70 degrees. And it's still a right triangle with a 90-degree corner in this corner. How far is the Coast Guard ship from the ship in distress? Well, what we'll do is we'll use the tangent function to find the distance of the Coast Guard ship, and we'll also use the tangent function to find the distance of the ship. So I'll grab my scientific calculator, and we have the tan of 70 equals 85 over x. So for, I'm doing the second one first. The tan of 70 equals 85 over x. So multiply both sides by x, and we get x tan 70 equals 85 feet. Divide both sides by tan 70, and x equals 85 divided by tan 70. And we get a distance of 30.9 feet, 30.93 feet. So the base distance of this triangle is 30.9 feet from the shore. The next thing we'll do is we'll do the same tangent function for the distance to the sailboat ship further out at sea. So now we have the tangent of 10 degrees equals 85 over x. That's for the red triangle down below. And I'll erase the parallel that was used for the depression idea here. Okay, I'll just draw that as a yellow guideline. But that's the invisible line going out this way. And also here, this is showing if this is parallel to this line going directly. These yellow lines are parallel. Okay, so we get 70-degree depression and 70 degrees inside the triangle from the Coast Guard ship. So if tan 10 is 85 over x, we know that 85 divided by tan x will give us x. 85 divided by the tangent of 10, is 482.06 feet. So 482.1. So since we want to know the distance, since the entire distance is 482.1, but we want the distance from where the Coast Guard ship is, which is at location X, we really just want the distance 482.1 minus 30.9. So the entire base is 482.1 minus the 30.9, which is just the distance from the lighthouse to the Coast Guard ship. And we get 451 feet. This will be rounded to the nearest foot. So the answer is 482 minus 31 equals 451 feet. And that's the distance between the Coast Guard ship to the ship in distress. So that would be the most advanced type of Sohcahtoa problem on an SAT. There are other types of problems on the SAT that include coordinate plane problems, such as finding distances on the XY plane, rules of slope parabolas and circle graphing. So we'll look at a few of those examples next time in the next video, which will also include probability and statistics problems and charts and graphs. Okay, We're going to take a break now, and I'll continue with the second installment of the SAT final review here at Chang Learning. And thank you once again for enrolling in this course. Thank you.